Hello, I hope you are doing well and having a good day. I'm the Amateur Logician from amateurlogician.com, and I want to explore with you some more facts about parabolas. And in previous videos, we thought about the vertex of a parabola. We thought about various ways we can think about the vertex, how we can derive it. For example, one good method is to think about the vertex form of a parabola, and that's y is equal to a times the quantity x minus h squared plus k. And if we think about that graphically or visually, it becomes intuitive that the vertex must be located at h comma k. And we can take that equation, that vertex form of a parabola, and then square that x minus h to get this, and then distribute that a to get this. And then we can take the standard form of a parabola, ax squared plus bx plus c, and set it equal to that vertex form, and then link the coefficients. And so we can then say that b is going to equal this minus 2ah. So we then get b is equal to minus 2ah. We solve for h, and we get b over minus 2a. And that must indeed be the x-coordinate of the vertex, and in fact is. Now, in another video, I said as a bonus feature, so to speak, that we can think of the vertex another way. So let's say we have y is equal to a times the quantity x minus r sub 1 times the quantity x minus r sub 2. Now in this case, r sub 1 comma 0 and r sub 2 comma 0 are x-intercepts. Now to be sure, there may be no x-intercepts, so we might be dealing with imaginary or complex numbers. That's certainly possible. But right now, let's just assume that r sub 1 and r sub 2 are real numbers. So if we think about this graphically, roughly we get something like this. Here's x, here's y, here's our parabola, here's r sub 1, here's r sub 2. Now the vertex, graphically, is going to have to be halfway between r sub 1 and r sub 2 because there's a symmetry about that vertex. So the distance between r sub 1 and r sub 2, half that distance, must be where the x-coordinate is located. And let's prove that. So first, let's think about it this way. We're going to take our equation, y is equal to a times the quantity x minus r sub 1 times x minus r sub 2. And for simplicity, I'm going to divide everything by a. So we get y over a is equal to the quantity x minus r sub 1 times the quantity x minus r sub 2. So let's expand that right-hand side. So we get x squared minus r sub 2x minus r sub 1x plus r sub 1 times r sub 2. We can then take this expression here and factor that minus sign and that x. So we get x squared minus parentheses, and then we're going to resort to the commutative rule to have r sub 1 first. So r sub 1 plus r sub 2, that's in parentheses, times x, then plus our r sub 1 times r sub 2. The next thing we're going to do is we're going to manipulate this equation to put it into this vertex form up here. So to do that, we're going to have to complete the square. So we're going to complete the square, and that's b over 2 quantity squared. That will complete the square. So right now we have y over a is equal to x squared minus parentheses r sub 1 plus r sub 2, close parentheses, x plus r sub 1, r sub 2. So let's complete the square now. So our b is really this right here, this minus parentheses r sub 1 plus r sub 2, close parentheses. So we'll say parentheses minus parentheses r sub 1 plus r sub 2, close parentheses, over 2, that's squared. But we don't want to alter our expression, so we better also subtract that. And I better move this because I don't have enough room. So let's do that. I'll put this down here. So let's subtract that as well, because we don't want to change our expression, our equation, to something totally different. So parentheses minus parentheses r1 plus r2, close parentheses, over 2. That whole thing is squared. So now, this x squared, this minus parentheses r sub 1 plus r sub 2, close parentheses x, and this will form a perfect square trinomial. That's, so to speak, the magic of completing the square. So now we have, on the right-hand side, parentheses x minus r sub 1 plus r sub 2 over 2. Quantity squared. Then we have plus r sub 1 times r sub 2 minus parentheses r sub 1 plus r sub 2, close parentheses, over 2, and that's all squared. I'm going to stop right here. I'm not going to mess with that because that's not that interesting. But notice that if we think about y is equal to a times the quantity x minus h, quantity squared plus k, we know the vertex is at h comma k, so that means it must be this right here. So in other words, h is equal to r sub 1 plus r sub 2 over 2. Or in other words, if we think about this graphically, it indeed is half the distance between r sub 1 and r sub 2. And that's what we just shown. Pretty cool. But we can also think about it this way. So once again, y is equal to a times the quantity x minus r sub 1 times the quantity x minus r sub 2. We can expand that out, so to speak, that right-hand side. So we get a x squared minus a parentheses r sub 1 plus r sub 2, close parentheses x, plus a times r sub 1, r sub 2. And we can link that, so to speak, to y is equal to ax squared plus bx plus c. Again, we're thinking about the coefficients. So this minus a times the quantity r sub 1 plus r sub 2 matches up with this b, for example, right? This c matches up with a times r sub 1 times r sub 2, which is also kind of interesting. So let's just say that. So we see that c is going to equal a times r sub 1, r sub 2. I don't know why I put that up there. There, that's better. So that's c. But also, note that b is equal to minus a times the quantity r sub 1 plus r sub 2. b over a, negative there, is equal to r sub 1 plus r sub 2. Couldn't we just multiply both sides by 1/2? Sure, we can do that. So let's just do that. So minus b over 2a is equal to 1/2 times the quantity r sub 1 plus r sub 2. Look there. The x-coordinate of the vertex is halfway between r sub 1 and r sub 2.